Hello class, today we are going to talk about the first part of section 2.8, which covers literal equations. The next video will cover the second half of 2.8, which talks about dimensional analysis. At the end of today's video, you will be able to rearrange equations to solve for a specific variable within the equation. A literal equation is an equation that involves more than one variable. So up until this point, all of the equations that we have been looking at have just had a single variable that we are trying to solve for. Now we're going to throw more than one variable into the equation. So, for example, this starting equation that we have is 15 is equal to 3n plus 6p. So we've got two separate variables. We got n and we have p. The idea of literal equations is that we can rearrange them to solve for one of the variables. So the first half of this problem is asking us to rearrange for n. Just like solving for a variable in any other problem, that is the one that we want to have set aside by itself on its own side of the equation. So I need to get rid of everything else around this n value. Still going to use the idea of sad meat to move things around. So if we want n to be by itself, the first thing I need to get rid of is any addition or subtraction. So we're going to subtract 6p just like we would subtract a regular number 6. Now, remember, when you are subtracting things, you can only combine like terms. Since 15 doesn't have a p with it, we're going to have 15 minus 6p is equal to 3n. We can't actually put 15 and 6p together because they are not like terms. The last thing we're going to have to do to get n by itself is divide by 3. I have to divide the other side by 3 as well, which means I have to divide all of the pieces on that side by 3. So since there's two separate terms, 15 and negative 6, I have to divide both of those by 3. So this ends up giving me 5 minus 2p is equal to n. So I have solved that equation so that n is by itself. The other thing it could have asked us to do in this problem is solve for p. Since there's two variables, you can solve for both of them. So the first thing I would want to do on this problem is subtract the 3n. Again, we're trying to get the p to stay by itself this time. Same as before, we can't put the 15 and the 3n together because they are not like terms. And the last thing we have to do on this one is divide by 6, which we have to do to, again, all of the pieces involved on the other side of the equation. So I end up with 2.5 minus 1/2 n is equal to p. So you're able to rearrange for either variable so that you know, depending on what they ask, you can solve for n or you can solve for p. So go ahead and try to solve this particular equation for g. You should have gotten a final answer of g is equal to 37/8 minus 1/2, or if you wanted to put that in decimal format, it would be g is equal to 4.625 minus 0.5y. Both of those would be acceptable answers if you want the decimal version or the fraction version. Some of our equations are a little bit more complex. We've got 3x minus 2y is equal to xz plus 5. It wants us to solve for x. So this means we need to get all of our x's to the same side of the equation. Just like when you have variables on both sides, you want to combine those variables first. So we want to get the x's to one side of the equation. So I'm going to subtract xz from both sides. You could do it the other way around, that's fine. It doesn't really matter which way you pick. Your answer would just be flip-flopped at the end then. Again, the goal is to get x by itself. So we want to move everything that doesn't have an x to the other side of the equation. So the next thing we're going to do is get rid of the 2y. That way, 3x has an x, and negative xz has an x, and that's equal to 5 plus 2y. So the things on the left side have x's, the things on the right side do not. We still need to try and get that x by itself. This is where we're going to use something new to us, which is called the reverse distributive property, which is what is undoing the distributive property. So just like if I had 3 times x plus 7, I can distribute the 3 in and get 3x plus 21. I can do the reverse of that as well and pull the 3 back to the outside by dividing both of those values by 3. So you can distribute by bringing the number in, or you can undistribute by bringing the number out. In this case, we need to use the undistribution. We're going to bring the x to the outside. So if I take an x out, I'm left with 3 from the first part. Dividing by x gives me 3 left over, and z from the second part. If you were going to redistribute, you would end up with 3x minus xz, so you can always double check by just distributing back what you had. So we took the x to the outside using the reverse of the distributive property. So now it's saying x times 3 minus z, and we need to get rid of that. To undo multiplication, we need to do division. So I'm going to divide by that whole piece, which is 3 minus z. I'm going to divide that whole side by 3 minus z. Since we have some subtraction involved, there's really no way to simplify that. So our final answer for this is x is equal to 5 plus 2y over 3 minus z. Go ahead and try this next one on your own, solving for a. Make sure you get a on the same side first, and then solve from there. So I started by subtracting 8a from both sides. You're going to need to rearrange, and you get a final answer of a is equal to 23 over q minus 8. Last thing we're going to talk about, same kind of idea. We have to solve for the radius. This is our circumference equation. So we want to get the radius, or the r value, by itself. In order to do that, we're going to divide both sides by 2 pi. So I end up with an answer of c over 2 pi is equal to r. Your book might ask you to continue to use your new equation. So for example, what is the radius if c is equal to 75.36 centimeters? So it wants you to plug that value into the new equation that you have used. So go ahead, plug that in for c and find the radius. So you should have been doing 75.36 divided by 2 pi, remembering that pi is 3.14. And you get a final answer of radius is equal to 12 centimeters. If you have questions about this or anything else we've done during this lesson, please let me know when you get to class.